All right, hey guys. So what we're going to be doing right now is going through the first example on limiting reagents. So I'm going to read the question and then we're going to start the problem. So a 1.25 gram piece of magnesium, okay, is placed into a 80 milliliter solution of 0.113 moles per liter hydrochloric acid. Okay, so let's just look at that and just say to ourselves, okay, magnesium. Magnesium is a metal. Metals are solids. So immediately, I have to always start every question if I'm doing stoichiometry. So this unit, for every question, I basically need a balanced chemical equation. So the first thing I'm going to do is say, okay, magnesium solid is one of my reactants, and it's reacting with hydrochloric acid. Now, sometimes hydrochloric acid is a gas, hydrogen chloride. Sometimes it's aqueous. How do we know which one this is going to be? Whenever a question gives you a concentration, that concentration represents a solution, which is aqueous. So that means here, I'm going to write HCl aqueous. Okay. Now, what type of reaction is this going to be? Okay, well, I have a metal and then I have an ionic compound of sorts. So chances are this is going to be a single replacement reaction where magnesium is going to switch with the cation of this, which is hydrogen. So hydrogen is going to come out. And when hydrogen comes out by itself, it's H2 gas because it's diatomic. And then magnesium and chlorine are going to form MgCl2. Okay. All right. That's my balance. Well, that's my chemical equation. Now, the only thing that I need to do is make sure that it's balanced. So let's look at that. If I look on the left side, I've got one magnesium, and on the right, one magnesium. All right. On the left, I've got one hydrogen. On the right, I have two. So I need to put a 2 here. Okay, hydrogen's now balanced. I now have two chlorines, chlorine's balanced. So we're done. Now, the question here in step A just says which reactant is the limiting reactant. So we're looking for which one of these two chemicals is going to run out first. Now, what I recommend to you is even if you don't understand the question, even if you don't know what to do, but they give you information about magnesium hydrochloric acid or just reactants in general, just write down that information and then we can see what we can do. So in this question, they've given us a mass of magnesium, 1.25 grams. And they've given us a volume of HCl, which is 80 milliliters, but we only like liters. So it's 0.080 liters. And they've given us a concentration of 0.113 moles per liter. Okay. If you just look at this information, let's just think about what we could possibly calculate, and then we'll get to the question. If I have a mass of a solid, what can I calculate? Well, if I know the molar mass of magnesium, which I believe is 24.31 grams per mole. Let me check my data booklet. Yep. What can I calculate with mass and molar mass? I can calculate moles. Moles is mass over molar mass. Okay. So let's do that. Again, we kind of have an idea of what the question's asking, but if I have a mass, I can immediately calculate the moles by using this formula. Okay. It's not my final answer, so I'm not going to round it just yet. 1.25 divided by 24.31. We're going to get 0.051419 ... moles. So this is how many moles there are of magnesium. Okay. Now, let's calculate the moles of HCl because I have volume and concentration. And I remember in solution stoichiometry, moles is equal to concentration times volume. Okay. All right. So if I look at these two numbers, guys, these two mole values, okay, which one do I expect to run out first? Which one's going to be used up completely first? Is it going to be magnesium, which is 0.0514, or is it going to be HCl, which is 0.00904? Essentially, at this point, all I'm doing is looking for the smaller number, okay? So I expect HCl to run out first. However, before I can say which one is the limiting reagent, there's one more thing that I have to do. Okay. What I have to do before I can decide which one of these is going to run out first, truly, is I have to divide by the coefficients. Okay. So these are the moles that are present, but when they completely react, I want to figure out which one's going to run out first. So I'm going to divide this mole value by 2 because there's a coefficient of 2. And I'm going to get 0.00452 moles. Okay. So that is the amount. This is the amount of moles total. This is the amount of HCl that is going to react. Okay. This is how much there is. This is how much is reacting. Let's do the same for magnesium. Well, the coefficient here is 1. So I'm just going to divide by 1. If I divide this by 1, I get the same thing. 0.0514 ... And that's how many moles could possibly react for mg. Which one of these numbers is bigger? Magnesium. Which one's smaller? HCl. So which one of these is going to be used up completely first? Is it going to be the bigger number or is it going to be the smaller number? It's going to be the smaller number. The smaller number will be used up first. So my limiting reagent is going to be HCl. Okay. So you can write limiting. I always just like to put limiting reagent kind of above the mole value. Okay. Now that's part A. All right. Hopefully that's clear. Part B says how much of the excess reagent is going to be left over. Okay. If HCl is my limiting reagent, then Mg is my excess reagent. If I want to figure out how much is going to be left over, I need to calculate the moles left over. Okay, the moles left over of the excess reagent. Okay, let's just think about this logically. If I started with this many moles and I used up this many moles, how much is going to be left over? That's what it's asking. So the moles left over, guys, is going to be the moles of the excess reagent, okay, minus the moles of the limiting reagent. That's going to tell us how much is left over. So I'm going to do 0.0514 ... moles minus 0.00452 moles. So let's do that. Okay. All right. And I'm going to get 0.0. Sorry, can you see that? Yeah, black is a bit fading right now. 0.04689 ... moles. Okay. Let me get a better colored marker so you can see that. So at this point, guys, I started with this much magnesium. I reacted this much because that's how much there was of hydrochloric acid, and I'm left over with 0.04689 moles. Okay, this is my final answer. You can write sig digs if you want because of final answer, but I just want to show you one more thing. So I started with 1.25 grams of magnesium. After this reaction, I can figure out the mass left over, because the mass left over is going to be equal to the moles left over times the molar mass. So I can just take this number of moles, multiply by 24.31, and I'm going to get 1.14 grams. So I started with 1.25. I ended with 1.14. How much actually reacted? So guys, if I want to look at the mass of magnesium that actually reacted, I subtract them and I get 0.11 grams. Okay. This down here is extension. It's not what the question's asking. What the question is asking for is the limiting reagent by dividing and getting the smaller number of moles and figuring how much is left over. This is just something that is kind of interesting to think about. Okay.